Hi, good afternoon. Hello. Hello, are you there? Hello, can you hear me? Good afternoon. Hello. Yes. Can you see the desktop? Can you see? Can you see my desktop? Hello. Okay. Today lecture is about. Okay. Today lecture is about hashing or hash table. Okay. But before we go to how to use or how to implement the hash table, we talk about the motivation, why we need to study hash table. Okay, why? First question. Hash. Question is why? Okay, let's talk about why. Okay, in the reverse lecture, previous lecture. Sorry, because I cannot connect my iPad to my computer because due to the computer network or the network traffic is quite slow. So let's talk about reverse lecture. We study about list, right? So, for example, list is the DNA data structure. It helps you to store a lot of items in linear order. So, if that, you can use array list. It means that you store the item continually in memory, or you can use linked list. Linked list, right? And each of the items stored in node and node connected by single link or double link, right? Here. But actually, we talk about here. For array list, a symbol that is what I mean, the memory container. Item are for continuous. And in the case that if the item, then you are able to search item. Search any item which costs bigger of log n. Again, I want to emphasize again, if you want to search item in the array list with very cheap code here, big O of log n, then the item must be sorted. And if not sorted, unsorted, then cost is big O of n. And here, the item here is the cost searching for item here. Big O of n. Okay, I want to emphasize that if you apply the data, if you want to store item using linked list or using array list, and without the sorting, then in order to sort item inside of the list, the code is linear, means that the big O of log n. Big O of n. Then what happens? If in that the searching cost or the searching time depend on the size or the number of item n here, any number of items. So that's why when the number of items become larger and larger, your algorithm is when you want to search, you search with very slowly, becomes slower and slower. Okay, that is big problem. It means that you cannot scale your application into large to work with the big data because it's really slow, really slow. Or even that is log n also depend on the n, right? It depends on n. So that's why depending on that, when you give you the number of the value of n, you can easily compute the log n. So that depends. So that is similar. The data is when it becomes larger and larger, then your algorithm becomes slower and slower. Okay, one more data structure. Let's talk about tree. Tree is the tree. And then the better tree version here, we consider about the binary search tree. For the binary search tree, now we call the BST. The first case, if very good, that is you have the balance BST. Balance BST means that the height of the left subtree subtract for it means that the value of height subtree left subtree subtract for the height of the right subtree is less than or equal to 1. Okay, less than or equal to 1, right? Only. For it's satisfied for every node in the binary search tree. If like that, then in order to search one item, or we call searching cost a big O of log n. Okay. Again, here corresponding to the binary search in the array list. But another, if unbalanced BST, then searching code here big O of n means that linear. So you can see at the summary, if you want to store the data in linear or maybe the non-linear look like tree, the typical code right now is log n, and log n still depend on n, still dependent. And when the big data means that the n is very large, then log n is still also very high. Okay, that's big problem. Big problem. So that's why it comes to the question. Any tenant? Okay, provide searching cost. A big O of C means that the constant, and it's less than the big O of log n. The big question here: if you are able to store item and you are able to search the item with the constant time, what I mean big O of C? Big O of C, it means that the constant time. It does not depend on what? The number of items. Number of data items. It means that your data, you can scale your application to work with big data. Because if you want to increase the size of data size, means that the number of items become larger and larger, your item still working the same time, searching the same time. It's really good. Even that your application can work with big data. Your application. Very good, very important. And we hope that the constant time but much less than, remember just one symbol here just less than, but I give the two double here means that a lot. Okay, much smaller than the log 2n. Okay, if we hope like that. The question is how? Okay, the answer is hashing, isn't it? Or we call hash table, or we call hash map. Just name hash map or hash table. Or again, another concept, we had hashing. When talking about hashing, it's the same as lookup table. Lookup table means that the table provides you the capacity for lookup. Lookup means that the randomization. It's very fast. Okay, that is the way. So I tell you about why we need to study hash success internet. Any question for me right now? Just introduction. Hello? Any question? Are you there? Without response from you, without any talking from you, okay? It's really difficult for me to complete the lecture. Just one way lecture, okay, not good. Can you hear me? Hi. No question, right? I think you can turn on the microphone and then you can talking with me, the better. Just motivation only. And now we go to the hashing. Sure, you can search on internet for hash table, okay, or hash map. But now we use our data structure. Yeah. Hello, can you hear me?
Yes.
Okay. Now let's talk about here. We had the interface. Let me identify the interface look like the order, the data structure. I define the IMAP here for you. K and V. What I mean, our data mean that the hard map depend on the two kind of data types. K stand for key and V stand for value. If without the hard map will look like you create the associate or the mapping between key and value, key and value, key and value. Okay, we had two important methods look like the foot. We create that we put a map between key to value. Okay, to the hard table. And after that, after the store, we had to get, okay, we can get very fast. We hope that here very fast, okay, very fast. So right now we have also a symbol. We had a class on hard map, S hard map. Why? Because in Java we had class hard map only. So that's why I don't try to use the same name. I use S hard map. If in Java, okay, like you can learn to use the S hard map, and then you can easy to learn the hash map in Java. Okay. So that is implementation. So that's why you have to implement the map to provide all of method inside of define inside here. Okay. We focus on foot and get before we go to detail. Let's talk about how to use first. Okay. So in our lecture, I want to tell you about first how to use. Next, how to implement. Right? If you want to know how to use and then how to implement, and then you understand very deeply about that. So how to use easy. First, you have to import. But right now, I need not to import. Why? Because our class here demo in the same package which DSA has, so you need not to import. Okay. Right now, let's talk about identify the demo. How to use here. In the main function, I create a map or mapping from integer to integer. it means that the key and value is the same data type, right now integer. And remember, here is your demo. In real application, you can reply and key and the value is different data type. Don't worry about it. Okay? Don't worry. You can change to any data type. So I create a map. Okay, I will plan this later. Right now, I can push. I want the map, mean that the map mean a half table, keeping the mapping from 2 key is equal to 2 value is 100. So I pass the look like in define the map here. You pass the key and value. So you can see you pass the key value, and then now I printing. I can print and then I show you about the table, how you can figure out about table. Here, you can see here the table. How you think about it? You have 10. What I mean? 10 then now is the capacity. What is capacity? 6 means that the number of the mapping you store. Right now you have 2, 3, 4, 5, 6. You can see that is the mapping. Here. For example, here 42 to 75, 67. Here. For example, you map from the 24 to the 42. Right, you put mapping. So here the table. Why we call it table? Because actually we store, I think that we can think here a list. We now actually I use double list. Bubble list to store the horizontal list here. We have 1 list, 2 list, 3 list, 4 list, 5 list. Actually, we have a lot of lists right now. 1 list at this each of entry here. Actually, we had a 10 list, but now list at index 0, list index 0, list at index 1 equal to empty, mean that the null. And similar list at index 7, 8, 9, also empty. Only 5 lists here different to null, or not empty. Okay, so here the picture of list of the hash. Here the picture of hash, very simple. Why we call table? Why we call table hash table? Because you can see here, actually, 0, 1, 2, 3, 4, 9. That is the array. Look like the table. Okay, the array. That is the array. And for example, here, this array at the item at index 0, it keep null. Item at that 1, it keep null. And item at index 2, it keep what? It keep the reference to the first entry. I mean that the first pair 42 to 6 to 7. Right now I do like that. When you declare the array, the item type right now here, the pair, it keep the reference of pair, the first pair. And here, the first pair point to the second pair at index 2. Because we had a double list, so that's why you had the pointer from net of the pair I highlight here, net of this point to the second. And of this reverse the prep pointer, because if you look at the double list, you can see revert pointer point to null. Okay, that is why how to think about double list. So you can see that is the way of I use the mapping. To you, net, how I find icon, how I get the value from key. Here I use get method. How to. For example, if I specify key equal to 24, and I pass the key go to the get map.get of we pass key, and then you get the value. Now you can see if you pass key equal to 24 here, then the V must be 42. That is expectation. Look like here. Here. 42. So you can see here the value 42 associated with key 24. Here, the code here. It returns you the V, and then now if V equal to null, you say that the key is not found. You print out key not found. And L means that the key you print out the value associated with the key. So why now you can see it print out correctly. Here. A simple how can I look up the value of 45? For example, let's say 2. If I pass the value, the key equal to 2, then value must be 100. Let's see. Okay, and I run it. You can see right now here, the value is 100. And what happens if I pass the key not found here? For example, I give the value, let's see, 99. The key 99 is not stored here, right? It returns not found. Actually, it returns null. It returns null, but the null is mean that not found. Okay, so I check null here, not found. So 99. What happened here? Okay, not found. So okay. Hello, can you hear me? Any question? Hello, are you there? Can you hear me?
Yes.
So I told you about how to create the hash map or hash table, and how to put the item, to put a log of item, and then how to search. Now search now right now is showing me that the get key value. Okay, you can see you can get key very fast, and you hope that here really fast and as fast as possible. And the best one is the constant time, and it's much less than the big O of log n. It must be log n. Later, I can provide, I can devote this why the constant time and why you can provide the this relation. It means that the time is much less than the log linear log time. Okay, I can revolt that later. So you can see, okay, easy, just put and get. But not only put and get, you can query about the empty. Empty means that the sign means the number of item equal to 0 or not. Or you can create a sign. Okay, very simple. It's simple. Or you can remove the key also. Let's talk about what happens if I remove key. You can see how I change here. As simple if I had a 34, but now I put the 34 here, it must return 42, right? You can run it, you can see. Right, you can see. Sure. Here. But what happens if I remove? Map dot remove. I remove the key right now here. 24. I print it again. Okay, I print it again and dump it, and then you can see before removing, you had that table. And in that table, you can easy to verify, okay, they are the mapping from 24 to 42. But after remove, okay, it's gone. Okay, it's gone. And in that 4 here, it's gone. And so why it's gone? So when you get the key, get the value associated with 24, it's not found. Very simple. Or you are also remove not only key, but you want to remove key to value. Okay, depend on you. Okay, let's say if you want to remove 24 here, no problem. Okay, and the same. The behavior the same. Yeah. Okay. Similar. Or you can verify order. Let's say you check that the map contain the key or contain value. Okay. Let's talk about. I verify that I remove it. Now boolean value. Okay, file equal to let's map dot contain. You want to contain key or value. Let's say contain value. Contain key. Sure, 24 again. Okay. Sure. You can copy like this. You put here, and now not v, but now found, not found. Not found like that in Java. Okay, you return. Sorry. Not found. Why not found is like that? Let's see. Here, okay. So can see. Open. Sorry, recently I used the pattern a lot, so it's only use the pattern. Can see easy to verify content key here. Sorry. Okay. What happened? What là that? Oh, right. Wow. Hello, are you there?
Yes.
Okay, why slow? Why slow here? Okay. Here you can key 24 default. Without you can find the 24 key there. And okay, the similar for the content value. So you can see I think for the hard table, almost the symbol we had a put, get, remove, and content key, so on, right? It's simple. So how do you? Okay, I want to finalize. Do you know how to use HotMap? I did explain about how to use first. Any question? Hello, any question? Because I want to go about how to use, or go to how to element. Okay. How to? Hello, are you there? Any question about how to use HotMap? No.
No, sir.
Okay. So let's talk about how to element. So we have to the half function first. What do I mean half function? Actually, I answer here. Any question provide the solution code with the constant and it much less than the log n. The answer is hartable, but actually, which would or appropriate half function? What do I mean? It means that not on hartable can provide you the constant time. Not on. Okay? Not on. It really depends on the, how good your function is, how good the half function is. So the most important, you have to design good. Okay? So that's why net have to design what? A good half function. So half function, what do I mean? First, what it is? Half function. What do I mean half function? Concept. The half function. Sure, I need a function. Sure, okay, it's a function. To transform key to location in table. Or we call location in table, but the table we use array. We use array. So that location in table, it means that in that. Again, because you want to store the data of any data type, key of any data type. So that's why you have the way to transform the key to the location. Key to location. For example, the key may be student, might be object of class the student, might be object of class table, might be object of class toy, or so on. Any, you don't care. In real application, actually at the time right now, when I design the hard map, I don't know in future the user use to hard map, my hard map to store what kind of data, I don't know. Okay, that I provide here key. So that's why you have the way to transform to the location. Look like here. For example, here. 0, 1, 2, 3, here the table, right? Can you see? Hello, are you there? Can you see the table vertical here? It represents for the table. Which index 0, index 1, and so on.
Yes.
So let's talk about now assume that I use very simple. I use very simple hard table here. That table for what? I use that table here. I get the hard code. I get the hard code from your class, the user class. And then that is value. Remember that is the value, integer value. So I modulo for this. In Java, what does it mean? Percent operation. Simple. Hello? In Java, what does it mean? In Java, meaning of this symbol, operator. Can you tell me what does it mean? Hello. What does it mean? Trường An, are you there? Modulo. Thank you, Quang. Du Vinh or Quang, hello. Nguyễn Quý, Vinh Quang or Quang?
Yes.
What is it? Vinh or Quang?
My name is Quyền.
Quyền, okay, thank you. So what do I mean? Let's talk about it. The hard code equal to 1090, and then let's say simple 99, and then you modulo for let's say 10 equal to 9. Okay. Why? Because 99 equal to 9 multiplied with 10 and then plus 9. So when you divide for 10, so that equal to 9, and then it remaining 9. Okay. But let's talk about, for example, 93 and you modulo for 9. So that equal to 3. Okay? Return you 3. Why? Because 93, that equal to 9 multiplied with 10 and plus 3. So here, when you divide 93 for 10, that equal to 9 and remaining 3. So that we call modulo. And symbol. Okay. What is the feature of modulo operator? When you modulo for number, let's say 5, then the result n, any value n, you modulo for 10, that is equal to r. And you can see r always belong to, let's say, in what? 0 or 1 or 2, 3, 4, only, not 5. Remember, when you modulo for 5, the result must be 0, 1, 2, 3, maximum before, not 5, 6, 5, not 5, 6, or so on. Okay, that's important. If that you modulo for any value m, then the remaining must be from 0 to m minus 1. Okay, in general. Okay, that's the feature. Back to here. Assume that I use very simple hash function. And by this, what do I mean by this? By this, it means that in future, if the user want to use my hash table, hash map here, if the user want to use my library to store the mapping from key to value, then they have to override the method hash code. They have to override because inside here I get the hash code. Okay, so that's why I should require the user of our library must be override hash code function for key. Okay. Okay. Let's talk about here. Now assume that I have that hash function. Here we call hash function. So how now? Okay, the question can you? I had to explain why I store the mapping 42 to 73. 67. Remember 42 here to the value 67. I care only key. Okay, don't care about value, right? So how about the 42? Why 42? Because right now the length of table right now is 10. In our code, length equal to 10. So 42 you modulo for 10, that equal to 2. Okay, so that's why you have to store at this location. Now next, why the number key 2 here, you store here. Why? Because 2 you take modulo for 10, then it's also equal to 2. So it's here. And similar for here. When you modulo for, let's say 3, you modulo for 10, that equal to 3. And 24 modulo for 10, that equal to 4. 45 modulo for 10, that equal to 5. And 16 the similar. Okay, so easy to know where is it to store. Again, so the hash function help you to transform your data, mean that the key, into the location, mean that in the table where to store it. But now, for example, let's see about here. You have 2 keys right now, 42 and 2. When transform, it's hit to the same index, mean that the 2. So we call collation. That concept collation. Okay, mean that the 2 or more keys go to the same location. We call collation. So how to resolve? I resolve right now here. How to store it? Simple. I use double chain, mean that it look like double elite. Why I told that similar to double elite? because in the bowling list you had a head and tail. Dummy note, okay, dummy note. Okay, I open that document first. Waiting for me. Stop and view. Can you see here? Can you see it? Hello?
Yes.
So you can see in the bowling list, as you the dummy note mean that here it doesn't contain anything. The orange note here we call dummy. Actually, your data here only the white box here, only 4 notes here. Dummy. How about in the entry in the hard map? I don't try to use the head and tail, okay? For symbol, not for symbol. So I told you about here. My implementation I use what? Okay. I store the entry, keep the pointer to the first data here, and the last data is for the noon. Okay. So I think that you can improve. Okay, you can use the bullet. Maybe. So okay, here. Only 2. So the question is next, how to store the notes. For example, here in the bullet, we call here note. The operator note. We here not a note, not note. But now we call entry. I'll talk about entry first. Okay. We have key in value. So one entry, or we call one node, you store key and you also store value. You have 2 reference, one go to net and one to reverse. It look like here. One go to net and one to go to reverse. But now here contain only data. No, I use the key value also. Key value also. I think okay, you can reconstruct the code and then you can use the double list or no problem at all. Okay. It means that you contain for each of the for each of the entry in the table you store the reference to the double list. Don't worry about it. Okay, no problem. Okay. So otherwise, if you had the entry, okay, how to do the hard map here, the table. That is array of entry. Okay, array of entry. So here you can here the vertical data here look like 0, 1, 2. It represent for the table, the array. So initial, by initial, if you don't specify anything, I create the capacity equal to 10. It means that the table contains maximum 10 items from 0 to 9. Index from 0 to 9. Okay, and the size sure now equal to 0. And what does mean net? I want to emphasize the concept about low feather. What do I mean low feather? Because actually our capacity is 9, is 10. But you don't try to store all of items. No. When the size hit to the 75%, you have to renew or mean that to rehash or you create a new table. You create a new table. Let's talk about right now. You can see. Right now you have 6 items, right? Now the table like that. Now what happens if I add one more? Map.put. Let's see, for example, 35. Don't have any file right now, right? And let's see about any value. Okay, any file. And map.print. What happened? Okay, now I add one more item and I print now, and then you can see there are 2 tables. The table before adding big map and the table before adding after adding. So you can run it, you can see. here. You can see right now, before adding, you had a table here, contain the capacity only 10. But after adding, just adding 1, you add in 1 and then you can see the new table, different. Okay, different. Now you can see right now here why before that sitting is still exists, right here. But now why go to the sitting? Because when you create new table, it doesn't mean that you keep the old data here at the same location. No. Okay, the step in order to we call rehash. How to rehash? What I mean, you have to allocate the new table bigger right now, bigger. How big it is? How big depends on you. Right now I double. Now I double. But you have to take time for what? For each of item here, now 6 items. You have to rehash. It means that you put into the new table. So when you put new table, it might be it's go to another location. Not it to the same location here. Not it. Not it. Okay. So how about here? Let's talk about the code inside. You can see the food. Now talking about food. Right? Where the key? So from key you get location first by index. Location now index. Okay, in that. You know only, right? Now because your table contain the entry. Entry what? Contain a reference to the first entry. What do I mean? For example, the item at this location contain null. Contain null at this location. But at this location, it contains the reference to this entry. So that's why it's not null. So you can see how to put item. You get where see. You get the first entry. If the first entry is null, okay, it's null. Null, you don't try to run the while loop. Null. You add here directly. When null, you add right. What I mean? Here, for the book here. You create entry by contain value, key, and value, and revert equal to null. Again, the revert of this item equal to null. Revert of this entry also equal to null. Revert of the first item on of the first item here equal to null. But net for example here, net go to null, get no null because it's the first one, contain only 1. But the net of this, net of 42 with the value set 67, it pour to the net item or net entry. Okay, and lot go to null. So you can see I create 1. And what I mean here, what I mean, I link what? When I push, but if the okay, let's see about I create a new entry. And then what I mean here, red equal to new entry. What do I mean? It may not before you remember at this location here, at this point, the new entry not added to the table. So that's why after edit, you want what I mean. It is the revert of the current first item. What I mean. After adding, you think if the after adding, let's see about what they mean. If I add one more item, let's see, for example, 13. If I add one more item, look like 13. 13, let's see about the value right now. The same, 13, no, don't worry. So you can see how to edit. You compare the 13, you find the location where I see 13, 15. Oh, 13. Let's see, 55. Down here, 55. 55 or 30. Where beneath it, you can see your length table right now. The length of table right now here is 20. So location in that equal to 55 modulo 420. Now 11. That equal to 15. All right. So it means that it must store at this location. But when you get the first item, then here only store one item. Okay, only store one item. So that's why you insert at the beginning. So if that you insert before that, you have to think about look like after adding look like this picture. After adding look like the picture. 55, 13, and go to net. Okay, this. And remember here also because doubling, so okay, doubling, so I took you one link like that. So here net of this must be go to this, must contain the reference of this, and river of it must contain this. Okay, so river of 35 must contain the new entry. Okay, that is the target of this. That is the goal of this expression. Okay, and after that you put the new entry to the table. You increase the item. Okay, the number of item, and you okay. I explain this ladder. So you just run and you can see. You just run. You can see here 55. Okay. So what is the purpose of this while? The while here is you travel on the chain here. For example, here you travel from here to here, or for here, or from here to here, or from here to here, right? You travel for each of list here, and you find for a key. If that is equal, you to update. If that is equal, you to update the value. But this, and you return. You need not to add anymore. It means that when you add the new item, but the same key, different value, then just update. What happened, for example, here? For example, here, what happened if I add, for example, here, 35, right? And then now we 109, mean that the value was different. So I add one more. Copy here. Now, the same key, but the value different. Let's say I want to here 9999. Then you can see that I not adding anymore. I need not to add new entry. I to update the value from 985 to 995, 99. Okay, just run it, you can see. Yeah. What happened? Yeah, you can see we change the value, the old value to the new value. That's all. So that's why you have to travel on the linked list and you compare the key the user specify with the key stored in the table. If equal, you to update. And here you go net. Why? Because you while up, you go net, right? Hello? Can you hear me? Hello, are you clear about how to perform, how to implement push method? Hello? Is it clear?
Yes.
Okay. Okay, let's talk about what the mean ensure factor. Now go back here. Why before adding 55 and 30, you have how many? 1, 2, 3, 4, 5, 6 items. But why when I add one more and then it increase? Let's see about. Here. Before adding, you can see this, and after adding, you can see this. Even that the table now different, longer, bigger. How big is that? Now I try to use double. Depend on you. Don't care about that. But now I try. But why like that? Because you want to decrease. You want to decrease the collection, the number of collection. So that's why you want to use bigger and bigger table when your data is larger. The number of data is larger and larger. Very simple. If you had if you go on the road, if only one alone, mean that you go alone and then no collection at all. If maybe you and then another car, okay, maybe have collection, but rarely. But when a lot of car or a lot of motorbike go to the same area and then easy to collect, so that's why 10%. It's easy to collect. So that's why you keep the same idea. You keep the number of item, the number of the item right now, mean that the size over the capacity must be lower than some value we call capacity. Here, right now here I keep lower than 75%. But how I element here? What does mean 75 and how I element here? You can see when I put after adding successful, I have to call ensure fellow feather. It's similar to the add array and also hard map heap, because in heap we also ensure memory. Now ensure low feather. What I mean here? You pass here the number of items, right? Number of items after adding. It means that 6 plus 1 equal to 7 only. You pass 7 right now. Now it's 7, mean capacity. And you can see the maximum number of items right now is integer of multiplication here. Can you tell me 0.5, 0.75? Right now, low feather. 0.75 multiply with how long is it right now? 10. That equal to 0.7445, right? 10 right now. Why 10? Here. But you increase, what I mean, you convert to integer by what I mean here. You equal to what? How much is it? Can you tell me?
7.
7. Okay, that equal to 7. It means that the maximum number you want to store is just 7. It's just 7. No, 6. Because you compare here, why I call it? Because here is equal. It means that when the mean capacity hit to the maximum, you only rehash. So that is equal. So that is only 6. If you remove it, that is 7, right? But now it's equal. If that it contains 1 less than maximum. So now 7 compared to 7, that is equal. That is equal. So that's why you have to rehash. Why rehash? The old table now, old capacity, you multiply 2. So 10 multiplied by 2 equal to 20. And you perform rehash. What does mean rehash? Rehash means that you create a new table. Create new table, look like here. Longer new table. And how to do? For each of item in the old table, you put it to the new table. So that's why you can change right now. You put it so that now before rehash 16 map to 767 map you store at 6, but now after mapping you store at 16. Okay, quite different because you perform rehash. Rehash means that for each of item in the old table, you put it to new table. Okay, so that's why we call rehash. So that's why, okay, you can see why when you add 55 map into 13, and then you only rehash, and now table is 20. But what if I change? If I change a change code here is not 041, but maybe that is old table plus with the, let's see, about 0 old table multiply 04145. What happened? Not 2, but 045. What happened? Can you tell me? But convert to integer anyway. So 10 multiply with the 145. What I mean? How many?
50.
Can you tell me? How many? 50, right? Because 10 multiply with 15, you can see now it's 15 different. Sorry, before. Now you go to 15. Capacity is now 15, not 20 anymore. And now you can see when 15. Now after it has 42, go to 45, go to 45 here. Before hashing, before in the old table, it's stored in that file, but now it's stored at 0. That's 0. I see it is quite different. So do you know what they mean in ensure capacity, ensure loading? Pardon me, ensure loading. Any question for me? Hello? Any question? No? Hello, are you there?
No question.
So, I have one.
Okay, how do you?
I see that when you rehash, the complexity is maybe cannot the constant. It depends on the size of your value now, your current value.
Actually, you don't care about when you don't care about the cost of hashing one. The cost of rehashing, you don't care about that because you just care about how fast forget only. The constant is not the cost of this method. One.
Okay, I see.
Okay, the cost of the guessing only, the searching for one item now you guess. Okay, by the way, Quan and any person, can you tell me about when, with what condition or which kind of the table you get to the very bad cost for get method here, and which condition it help you the best one? Okay.
I think that the number when we modulo file must be the prime number. So that
no, don't care about that. The prime value or not prime. But now my question is not like that. My question is, okay, I repeat my question is, okay, the work case. The work case for get method. And next question, when to hit to the bad case? You send me? Or lucky case? Can you answer me?
Yes, the worst case when on the hash value is equals.
Yeah, thank you, Quang. Okay, okay, very good. When if you design a hash function here, if you design a function here, where is it? Yeah. And then after hashing, all of the item return the same location. If not, the list very long, right? It becomes the linked list, very long. And then in order to sort it, you have to sort sequential, and it's still log n, right? Linear. Okay. Sorry, the work case. So what I mean the net for work bad case. What is the bad case or lucky case for method get?
All of the hash key are different.
Different. Okay. But not sure. Okay, differently, not maybe not. Sure. The better the bad case. I think I think what's your name?
Đức Luân.
Lung. Okay. Thank you. I think that is one of the very good. Because if when you after hashing, each of item here had a different key, a different index. If in that, how long for the list here? How long? How long?
Constant time.
Constant, but the how long is it? For example, if you have an item, right? If you after hashing, each of item must have different. Okay, all of item have different location. So how long for the list here? For here, how long is one for one, but in real life, in your condition, how long is it?
O of n.
No.
It's also one.
One. Thank you. One. One. Why one? One? Why one? Not two, not three.
Because if it's one, that means the value, the hash value is not indifferent.
Yeah.
All of it is different.
Yeah. Because you can see because after hashing, all of the item had a different key, different location. It means that for each entry here contain one and only one item, right? One and only one item. It means that very idea we call no collection, right? No collection at all. So that when you get how much they cost? One in the case. How much they cost? When? Hello, are you there?
Yeah.
How much they cost?
The best case is
constant. We did the constant, right? Very cheap, right?
yeah, it's O1.
Okay, BO1. So thank you. So okay, you already plan understand how much they cost for the bed key and work key and so on, right? Oh, okay. Right now we go to next for get very important. After you put a lot, maybe billion of items, maybe more. But when you get it, assume that you are lucky. If you're lucky, and then you can see you have to you get it very fast. But can you explain me why fast and how to eliminate? For example here, how I get for example 52, 42 here. Sorry, 22, 24 here. 24 here, the user get the 24. So I get the 24 here. I passing. It means that right now my code here I modulo for length. I modulo for 15. 24 modulo for 15 equal how many? 9, right? Why 9? Because 24 equal to 15 plus 9, right? So that's why that equal to after modulo you take the 9. Okay, just one division modulo, that is the division, and then you only go to list location. and then you hit to this list, and you are lucky right now. List contain only one item, so you just search sequential, but sequential just one item, and then it will return very fast. Here it's 42. So how do you eliminate? Go to get. The first you find in that location by a hash function. You get the entry. The entry store the first entry, the entry of the first item. If null, you go to return null. If not null, you have to search sequentially. You search sequentially, right? You search sequentially. So that's why right now, lucky because your list contains one item. You hit this at the first, and then you return. Simple. The code here. So you can see the get very simple, right? Hello. The complexity also low, and also low or not low depend on hash function. Okay, but we are lucky. If you are lucky, then it's very fast. Hello. Any question for me right now? Forget. Hello. Any question about get method? No. If no, okay, take break about 10 minutes. Minute the 15. 14. 40. Come back here. Are you there? Hello. Free, come back here at this.
Yes, teacher.
I want to stop recording.